Hello and welcome to the OCR Further Maths videos for Pure Core. This is Hyperbolic Functions 2, Inverse Hyperbolic Functions, and this is video 2.2, Differentiating Inverse Hyperbolic Functions. So we're going to start with differentiating inverse sine of x. So we start with y equals inverse sine of x, and first of all we're going to do sine of both sides. So we get sine y equals x. We're now going to differentiate both sides of this with respect to x using implicit differentiation, which you will look at in your A-level maths. When we do that, we get cosh y dy dx equals 1, which means dy dx is 1 over cosh y. Now, as our original question was in terms of inverse sine, we're going to need to convert this into sine rather than cosh. And we're going to do that using the identity cosh squared y minus sine squared y equals 1. So that means cosh squared y equals 1 plus sine squared y. So cosh y is plus or minus the square root of 1 plus sine squared y. So if we replace that in our function, you can see dy dx is 1 over plus or minus the square root of 1 plus sine squared y. Now, if you think about our original function, which was y equals inverse sine of x, and think about the graph of that, which you've seen in previous videos, you should remember that that's always an increasing function. So in fact, we're just going to need the positive square root here. So that means that dy dx is 1 over the positive square root of 1 plus sine squared y. And way back here, we had that sine y was equal to x. So we end up with dy dx is 1 over the square root of 1 plus x squared. Now, there is an alternative method to doing this, and that's using the logarithmic expression for inverse sine of x, which we've seen in previous videos. Have a look at going through this yourself, being very careful with the chain rule, and see if you can get the same answer we did on the previous slide. The method for differentiating inverse cosh of x is very, very similar. We start with y equals inverse cosh of x. So cosh y equals x. Sine y dy dx is equal to 1, so dy dx is equal to 1 over sine y. Using the same identity that we used before, we get dy dx is 1 over plus or minus the square root of cosh squared y minus 1. And again, referring to the graph of y equals inverse cosh of x, we're going to use the positive square root. So we get dy dx is 1 over the square root of x squared minus 1. These two results are really important. Both these derivatives can be found in your formula booklet, but make sure you look at the integration section rather than the differentiation section. So we're now going to have a look at an example. We're going to differentiate y equals inverse sine of 4x. Now remember, we're going to need to use the chain rule because we haven't just got x here, we've got 4x. So using the formula, we get that dy dx is 1 over the square root of 1 plus 4x squared. And then we're going to multiply that by 4 because of the chain rule. So we end up with dy dx is 1 over the square root of 1 plus 16x squared multiplied by 4. So our final answer is 4 over the square root of 1 plus 16x squared. Be careful when you're doing these questions to keep in mind that you're going to need to use the chain rule often as well. Okay, the next video in this section is 2.3, integration using inverse hyperbolic functions.